In the last class, we have discussed the classification of elementary particles, broad classification as fermions and bosons, and fermions being further divided into leptons and baryons being divided into nucleons and hyperons, nucleons consisting of neutrons and protons, and hyperons consisting of lambda, sigma, z, and omega minus particles. And we have also mentioned that leptons are fundamental particles, baryons are made up of 3 quarks, then you had the bosons which consisted of massless bosons and mesons. Mesons are made up of a quark and an antiquark, and massless bosons consist of photon and gravitons, and mesons consist of k meson, pi meson, and eta particles. So these are the particles we had discussed in the last session, and baryons are made up of 3 quarks. So now we'll go a little more into the details. Let us first discuss what are leptons and hadrons. Leptons are basically light particles. Leptons consisting of electron, muon, tau particle, and the corresponding neutrino associated with each of these particles and their antiparticles. Those are the particles in the leptons. Leptons are spin half particles. They are not affected by strong interaction. They are light particles. They are not affected by strong interaction, and they are associated with a lepton number. Lepton number is a quantum number. So lepton number is 1 for a lepton and -1 for an anti-lepton. Suppose you are considering the electron. So lepton number of electron, Le, is +1 for electron and electron neutrino. Nu E is the neutrino associated with the electron, that is electron neutrino. They are having lepton number Le equal to +1, and lepton number is -1 for the antiparticle. The antiparticle of electron is positron, and the antiparticle of neutrino, electron neutrino, is antineutrino of the electron. So these particles will be having -1. All other particles except these will be having lepton number Le as equal to 0. Now similarly we have lepton number L mu. L mu is 1 for muon. Muon is mu minus is the particle and its corresponding antiparticle is mu plus. Mu plus is the antiparticle of the muon and the associated neutrino. Mu is the neutrino associated with the muon, and these two are having +1 as the lepton number L mu, and lepton number is -1 for the antiparticle mu plus and the antineutrino associated with the muon, that is nu mu minus, and L mu will be equal to 0 for all other particles. Then corresponding to the tau particle, lepton number L tau equal to 1 for tau minus and the neutrino associated with the tau particle, that is nu tau, and it will be equal to -1 for the antiparticle of the tau particle, that is tau plus, and the antineutrino. This bar represents the antineutrino. Nu bar tau. For all other particles, L tau is 0. So this is regarding the lepton number. We'll be discussing about the conservation of lepton number when we'll be discussing the different quantum numbers associated with the elementary particles. Now these neutrinos are particles which are not having a charge. They are uncharged and its mass is unknown. They have they don't, as such its mass is not known. They are uncharged, so it is difficult to contain them. They are stable. Electron and its antiparticle positron are stable. Muon, it is having a mean lifetime of 2.2 into 10 raised to -6 seconds, and tau particle, it is having its lifetime is very very short, 2.9 into 10 raised to minus 23 seconds. That is the lifetime of a tau particle. Now, antimatter. Electron has got an antiparticle positron. Muon has got its antiparticle. Tauon has got its antiparticle. Suppose we look at matter. Matter as such we know is made up of electron, proton, neutron, etc., which are all matter. Suppose we had a matter that is made up of all corresponding antimatter. We will not be able to distinguish between an object made of matter and another object made of antimatter. It will behave the same way. But if a matter or a particle is interacting with its corresponding antimatter, they will interact in such a way that both of them will annihilate each other, releasing energy. If an electron meets a positron, they both will interact. They will no longer remain as particle, but they will remain as energy. That means gamma rays will be emitted. Electron positron annihilation. Matter will be annihilated, energy will be created. Now looking at Dirac's relativistic formula, from that the expression for the total energy of an electron, E is equal to, solving Dirac equation, the solution is E is equal to root of m square c raised to 4 plus p square c square, the whole under root. Both positive and negative roots are possible according to Dirac's equation. That means energy has got both positive and negative roots, means positive energy and negative energy. Both are possible. So both energies are acceptable according to the Dirac equation. So we will be having energy. The upper energy can also go up to minus infinity if you look at the negative energy. This is also possible. Just look at this energy level diagram. We are assuming that all the electrons are contained in this negative energy state. All the electrons are remaining here in a sea of negative energy. This is zero energy, this is mc square, the energy corresponding to that electron, minus mc square. So this is the negative energy part. All the electrons are assumed to be remaining in the negative energy state. Now if a photon of energy h nu is incident in such a manner that it is coming out of this negative energy state, once the electron is free, it will be having mc square. That means it has to move from here to here. So it has to contain an energy corresponding to mc square plus mc square. So this h nu should be greater than 2 mc square for an electron to come out of this negative energy, sea of negative energy, to be an ordinary electron. So when an electron reaches here, there will be a vacancy created in the negative energy sea, or there is corresponding to a hole in the negative energy sea. This is actually the antiparticle of the electron. This is the positron. An electron is coming out, correspondingly a positron will be remaining in the negative energy sea. So a photon of energy, a photon is incident, it is a gamma ray photon, it is incident on this sea of negative energy, releasing an electron and a positron. So an electron-positron pair is generated when a photon or a gamma ray of energy corresponding to greater than 2 mc square is incident on this negative energy sea. Neutrinos and antineutrinos. If you look at this object is spinning. This is the direction of propagation. A neutrino has got a spin in the anti-clockwise direction. This is anti-clockwise rotation. So if you look from behind, the neutrino appears to be spinning. And antineutrino appears to be spinning in the clockwise direction. You can make a correspondence. Anti-clockwise means it is neutrino and clockwise means it is anti-neutrino. Neutrino doesn't have a charge. It has only spin. Other leptons, muon and its corresponding neutrino. This is muon neutrino. They were discovered in the decay of the charged pion. Pion is another particle. It is a meson. Pi plus is decaying into mu plus and neutrino of the muon. Pi minus is decaying into a muon plus anti-muon neutrino. Mu plus is the antiparticle of the muon. Muon is mu minus. The particle is mu minus. Its antiparticle is mu plus. So a particle and an antineutrino, an antiparticle and a neutrino. Pi 0. This is a neutral. This is a neutral particle. It is decaying as gamma ray photons. So positive and negative muon have the same rest mass. So this muon is generated by the decay of the pion, and muon is also not stationary. It will decay. This is anti-muon. It will decay as a positron, an electron neutrino and an anti-muon neutrino. And mu minus will decay as an electron, an anti-electron neutrino and a muon neutrino. And muons form a majority of the cosmic ray secondary particle. We have already discussed the cosmic ray particles, and the secondary particles are mostly consisting of muons. Tau particles are almost having the mass double that of proton. They are very heavy. They are having a short lifetime and they will decay as electrons, muons or pions with their appropriate neutrinos. They are not stable.